All right, today we're talking about the kinetic molecular theory and Dalton's law of partial pressure. This is part 2 of the lecture we started last time. So today we're talking about the kinetic molecular theory. The first thing we're going to talk about is the movement and energy of gases. The kinetic molecular theory is a theory based on the concept that particles are in constant motion. So no matter what is happening, they are always moving. Gas particles have kinetic energy. Kinetic energy just means they have movement. So they are constantly moving. They have movement energy. Gas particles move quickly and randomly in straight lines until they bump or collide into something. Once that collision happens, they change direction but continue in a straight line after the collision. They're going to do this over and over and over again. So they are going in a straight line, they bump into something, they change directions, they continue in a straight line until they bump into something again. Elastic collisions is a collision during which there is no net loss of kinetic energy. Energy is just transferred between particles, but not lost to the environment. Temperature is the measurement of our average kinetic energy. All gas particles that have the same average kinetic energy have the same temperature. Average velocity of the particle of a specific gas, meaning that they have the same mass, are directly related to the average kinetic energy and the temperature. So how fast the particle is moving directly relates to the energy and the temperature of that gas. If a gas particle has higher average velocity at higher temperature, so we add heat, they speed up. We reduce heat or pull heat from the system, they slow down. Gas are composed of large amounts of very small particles. Compared to other states of matter, gas particles are far apart from one another and separated by large amounts of space. There are no notable attractive or repulsive forces between gas particles. So gas particles are neither attracted or repulsed by other gas particles. They just kind of exist amicably in the space. Then the physical properties of gases can be explained by our kinetic molecular theory, which we'll read about in the next paper that we read. But due to the large amount of empty space between gas particles, gases tend to have a low density, meaning that they are very little in weight, and have a high compressibility of any state of matter. So meaning it can be squeezed and pressed, unlike liquids and solids can. Gas particles can diffuse due to quick random movements. And diffusion is just to mix spontaneously without stirring. I like to think of it as if I spray Febreze in one corner of the room, the particles are going to randomly move and diffuse to the other side of the room. So you can smell the Febreze from one side to the other due to diffusion. Finally, gases are fluids, so they are in constant movement. They also flow past each other easily and expand to fill their container. That's all I have for you today. Come back for part 3 next time.